Tonight we're going to explore an object that is drifting past us at this very moment, quietly, without permission, and it is older than the sun. Not older than you, not older than the pyramids, older than the sun itself, older than the ground you're lying on, older than the water in your body, older than the first single cell that ever divided in a warm sea. It formed before there was a sun to form around. It was already ancient, already a traveller, already alone in the dark. And all of that was true roughly 3 billion years before the cloud of the gas that became our star had even begun to fall inward on itself. And right now, tonight, it is here. It is inside the boundaries of our solar system. It is a real thing, made of real ice and real dust, moving on a real path you could plot on a chart. It is not a story. It is not a theory about the distant past. It is a physical object, small enough to sit inside a city, and it is threading its way past the planets even as you close your eyes. Let that settle for a moment. Tonight, somewhere out beyond Jupiter, a frozen relic older than the sun is picking up speed and leaving. It came in from the dark. It will go back into the dark, and it will never return. It is called 3I Atlas. That name is going to feel strange at first, so let it soften as we go. The 3 simply means it is the third of its kind. The I stands for interstellar, which is to say it belongs to no star we know, to no system we can point to no place we can name. An atlas is the name of the telescope in Chile that caught it, one faint moving point of light on an ordinary desert night. Only 3 objects like this have ever been confirmed in all of human history. 3, across every civilization, every telescope, every pair of eyes that ever turned upward. The first came in 2017, the second in 2019, and now this one, the strangest of the 3, and the oldest thing any of us are ever likely to encounter. So settle in, let your shoulders drop. There is nowhere you need to be. Tonight we're going to follow this ancient traveller from the moment it was found, through the chemistry it carries, back to the impossible question of its age, and out again into the dark where it is already heading. By the end of tonight you will understand how a handful of scientists read the birthday of an object with no birth certificate. You will see why they are so sure it is older than the sun. You do not need to remember any of it. You only need to let it carry you down into sleep. Now let's begin. The night it was found, no one was looking for it. That is worth holding on to. No one was watching for a visitor from another star. No one had it circled on a calendar. It arrived the way most true strangers arrive, unannounced, into the middle of something else. The telescope that caught it sits high in the Chilean desert, in a place called Rio Hurtado, where the air is thin and dry and the ski is one of the darkest on Earth. It belongs to a survey called ATLAS, which stands for a longer, more anxious name. The Asteroid Terrestrial Impact Last Alert System. Read that again, slowly. Last Alert System. This is not a telescope built for wonder. It is a burglar alarm. It was built to watch the sky for asteroids that might one day fall on a city. Its whole purpose is to give us a few days of warning before something big and fast comes down out of the black. It sweeps the same patches of sky again and again, night after night, looking for anything that moves. Most of what it finds is ordinary. Rocks in the asteroid belt, known comets on known loops, bright things that were always going to be there. The system is designed to ignore the permanent and flag the moving, to notice the one point of light that is not where it was the night before. There is a strange poetry in the fact that this is the machine that found it. Think about what the system was built to fear. It was built for the day something comes down out of the sky and does harm, the asteroid nobody saw coming, the rock large enough to level a city. It watches for our own destruction, patiently, every clear night, so that if that day ever comes we might have a few days of warning to prepare. It is a machine born entirely of caution, of the knowledge that the sky can on rare occasions be dangerous. And this careful, anxious watcher scanning for threats, instead caught the single most harmless and most wondrous object it could ever have found. Not a threat at all. A relic. A stranger with no interest in us, on a path that would never touch us, older than the sun itself. The alarm went off, and what walked in was not danger. It was awe. On the 1st of July in 2025, it flagged one. Picture what it actually saw. Not a comet with a tail, not a glowing ball, just a single pixel of light, faint almost past the edge of usefulness, crawling across a wide field of stars. It was magnitude 18, which is a number that means very little until you feel it. The faintest star you can see with your naked eye on the darkest night is around magnitude 6. This thing was roughly 4 million times fainter than that. 4 million times dimmer than the dimmest star your eye can hold. A whisper of light, a rumour of light, and it was moving. Slowly, almost imperceptibly, from one exposure to the next, it shifted against the fixed background of stars. That shift was the only thing that gave it away. Everything else about it was quiet. At first, it was given a placeholder name, a string of letters and numbers, A11PL3Z. Not a name so much as a filing label, the kind of tag you give something before you know what it is. It sat 3.5 astronomical units from Earth, which is to say 3.5 times the distance from Earth to the Sun. It sat 4.5 of those same units from the Sun itself, and it was moving at around 137,000 miles per hour relative to our star. Sit with that speed for a moment because it matters. 137,000 miles per hour. That is not the lazy drift of an ordinary comet. That is fast. That is faster than the Sun's gravity can hold. And that speed was the first hint that this was not one of ours. Let me put that number in a frame you can feel with your body. A rifle bullet leaves the barrel at a few thousand miles per hour. A jet airliner cruises at around 600. This object was crossing space at more than 137,000 miles in every hour. And it was doing so far from the Sun, not near it, where the Sun's pull whips things along. Far out in the cold. Out there, any object born to our star would be moving slowly, dawdling, taking its long, lazy time. To be moving that fast, that far out, is like finding a stone skipping across a pond that no hand on the shore could ever have thrown. The energy had to come from somewhere else, from another star, from a shove given billions of years ago in a place we will never find, that had never once slowed down since, and it would only get faster. As it fell inward toward our Sun, the Sun's gravity would add to its speed. Near its closest approach, it would be moving at something closer to 150,000 miles per hour. That is among the fastest natural objects ever tracked through the inner reaches of our solar system. A frozen hill, older than the Sun, moving faster than almost anything we have ever clocked, and doing it without any engine at all, carried only by the memory of an ancient push. Astronomers around the world began to pull the object apart with mathematics. They took the handful of positions they had, night to night, and they fit a curve to them. The shape of that curve is everything. A rock that belongs to the Sun travels on a closed loop, an ellipse, a path that comes back around. It is bound. It is a member of the family. But this curve did not close. It opened. It flew outward and away and never returned to itself. There is a single number that captures this, called eccentricity. For a perfect circle, the eccentricity is 0. For an ordinary stretched-out comet orbit, it is somewhere below 1. At exactly 1, the path stops being a loop and becomes an open curve, a one-way road. Anything above 1 is unbound, a trajectory that was never captured and never will be. This object measured 6.14, not just past the line, far, far past it. 6 times past the threshold that separates a visitor from a resident. To put that in company, the first interstellar object we ever found had an eccentricity of around 1.2, just barely over the line. The second measured around 3.4. This one measured 6.14. Of the only 3 such objects ever confirmed, this was by far the most extreme, the most clearly, undeniably from somewhere else. There was no ambiguity. The mathematics did not leave room for doubt. This thing had come in from between the stars, and it was going straight back out. Within about a day, the world's minor planet bookkeepers made it official. The Minor Planet Center announced it on the 2nd of July. They gave it a proper designation, C2025N1, and then they added the mark that changes everything, the interstellar prefix. 3I, the third. And in that moment, a faint pixel over a Chilean desert became one of the rarest confirmed objects in the history of astronomy. There is something worth noticing in the name itself, in how it was chosen. This object is called for the telescope that found it, the survey, the machine. Not for a person. The first interstellar object was given a soft Hawaiian name. It means something like a scout, a messenger reaching out from the distant past. That name has a music to it, a warmth. The second was named for the amateur astronomer who found it, one man and his homemade telescope. But this one carries no human name at all. It is named for an instrument, for an automated survey sweeping the sky without sleep. There is something quietly fitting in that. This is a stranger with no human connection, no discoverer to shake its hand, no soft syllables to soften it. It was caught by a machine, and it wears the machine's name, and it will carry that plain, mechanical label out into the dark forever. Think, too, about the odds of catching it at all. Consider the geometry. Here is a small object, no larger than a hill, dark as old stone. It moves at 137,000 miles per hour. Its path brings it through our solar system exactly once in the entire history of the universe. It does not orbit. It does not return. It has one pass, one window, a few months of being close enough and bright enough to see. And in all the vastness of the sky, on the right night, at the right hour, a survey telescope happened to be pointed at the right patch of dark. A telescope built for something else entirely. Miss that window, and it would have come and gone unseen, as surely thousands of others have, slipping through unnoticed while we looked elsewhere. We very nearly did not see it at all. Think about how fast that happened. In earlier decades, confirming something like this would have taken weeks of careful, cautious work. Here, in about 24 hours, a scattered handful of astronomers across several continents went from "is this a normal comet?" to "this is not from our solar system." A compressed little detective story, run overnight, in the quiet way these things happen, over email and shared data and the slow accumulation of certainty. And then something lovely happened, the way it often does after a discovery. People went back and looked at old images. Because once you know where a thing is and how fast it is moving, you can run the clock backward and ask, where was it last week, last month? And when astronomers ran that clock backward for 3I Atlas, they found it hiding in pictures that had already been taken by telescopes that had no idea what they were looking at. There were images from an observatory in Israel dating back to the 21st of May, weeks before the official discovery. The object was already sitting in the frame, unremarked, unnoticed. There were images from a NASA space telescope called TESS, a planet hunter, that had unknowingly recorded it across most of the month of May and into early June. And here is the detail that should stop you cold. In those early images, the object was already active, already faintly wrapped in gas, already bright in a way it should not have been. It was doing this from 6.4 astronomical units out from the sun. That is far. That is well beyond the distance where water ice usually begins to boil off a comet. Out there it is cold, brutally cold, and a normal comet would still be locked frozen and dark. But this one was already breathing. Something other than water was driving it. Some more volatile ice waking up in a place where water still sleeps. That too was a clue, though it would be weeks before anyone understood what it meant. There is a particular kind of pleasure in this part of the story. the going back through old images, and it is worth savouring slowly as you drift. Every night telescopes across the world record vast fields of sky, capturing millions of faint points of light. Most of those points are simply logged and stored and never looked at closely. There is nothing to look for. The comet was in some of those old fields, sitting quietly in the data, a faint mover that no one had reason to notice. It had been photographed. It had been recorded. It had, in a sense, already been seen, over and over, by instruments that filed it away without a second glance. And only after the discovery did anyone go back to find it. Once astronomers knew what to hunt for and exactly where to look, they searched the archives. And there it was, waiting, weeks earlier, in pictures taken for other reasons entirely. The stranger had been in the house longer than anyone realized. We simply had not known to look at it. There is one more piece to the discovery that is almost too neat to be true. There is a brand new telescope in the Chilean mountains, one of the most powerful survey instruments ever built, called the Vera Rubin Observatory. In the summer of 2025, it was still in its testing phase, still being checked and calibrated before its real work began. And during that testing, purely by accident, it had swept across this very patch of sky and captured the comet nearly 100 times. Astronomers did the arithmetic afterward and realized something quietly astonishing. If Rubin's full survey had begun just 2 weeks earlier, Rubin would have found it first. This ancient traveller slipped in during the narrow window between one telescope's readiness and another's. It was caught in the end by the burglar alarm rather than the grand new instrument. There is a kind of cosmic timing in that, the sense of something arriving at exactly the wrong or exactly the right moment, depending on how you look at it. And notice the shape of the whole thing. A telescope built to watch for objects that might one day kill us instead found an object that was never aimed at us at all, something that had been drifting, in a sense alive since before the Earth existed. It was never a threat. It was just passing through, indifferent to us, on its way to nowhere in particular, and we happened to be here to see it. You can let all of those numbers go now. The designations, the magnitudes, the distances, they were only the doorway. What matters is the feeling underneath them. On an ordinary night, over an ordinary desert, a machine built out of fear caught a glimpse of something impossibly old. And for a moment a handful of tired scientists sat up and understood that a stranger had come into the house. Tonight that stranger is still here, still moving, and we are still watching it go. Now let it drift back out again and follow it, because the path it took through our sky is its own kind of story, and it is not finished yet. Tonight we're going to trace that path day by day, from its closest brush with the sun to the long, slow goodbye it is living out right now. Once astronomers knew what they had, the question became simple and enormous. Where is it going? And how close will it come? You can plot the whole journey in advance because gravity is honest. It does not lie about the future. Once you know an object's position and its speed, the sun's pull tells you the rest. Every turn it will make, every planet it will pass, the exact day and hour it will swing closest to the sun and begin the long fall back into the dark. So astronomers laid the path out ahead of time, like a train timetable for a train that only runs once, forever. Its closest approach to the sun, the moment called perihelion, came on the 29th of October 2025. On that day it passed within about 1.36 astronomical units of the Sun, which is roughly 130 million miles. That put it just outside the orbit of Mars, tucked inside the edge of the asteroid belt. Close enough for the Sun to warm it fiercely, far enough that it was never in any danger of falling in. There is a small, strange beauty in the timing of that closest approach. Around the same window, from our point of view here on Earth, the comet passed almost directly behind the Sun. For a stretch of days it was hidden entirely, eclipsed by the blinding disk of our star, invisible from every telescope on the ground. hold the picture of that. An object billions of years old, briefly blotted out by a star that had not even been born when the comet formed. The old thing tucked behind the young one, out of sight, waiting to reappear. Before that, it had already made a close pass by Mars. On the 3rd of October, it came within about 0.194 astronomical units of the red planet, which is roughly 29 million miles. And Mars, it turns out, has watchers. A European spacecraft in orbit there, called the ExoMars Trace Gas Orbiter, turned one of its cameras toward the visitor and captured it. This was not easy. The comet was faint, something like 50,000 times dimmer than the surfaces that Orbiter usually studies. But it managed to record the stranger anyway, a smudge of light against the black seen from the vantage of another world. Then came the pass by Venus in early November, within about 0.65 astronomical units. And after that, the moment many people had quietly wondered about, its closest approach to Earth. That came on the 19th of December 2025. And you can rest easy about it, because it was never close in any way that should trouble you. At its nearest, it was about 1.8 astronomical units from Earth, which is roughly 170 million miles. That is farther than the distance from the Earth to the Sun. There was no risk of collision. There was not even a near miss by the standards of planets. It simply passed, out there in the cold, a distant point of light going about its business, indifferent to us as it had always been. This is the point in the journey where I want to be honest with you about something the headlines sometimes blur. This object was never going to hit us. It was never on a path that threatened anything. The word passing in the title of tonight's story is not a warning. It is description. It is passing the way a ship passes a lighthouse far out at sea, close enough to see, far too distant to touch. You can let go of any worry you might have carried into this. There is nothing here to fear. There is only something to witness. There is one more watcher worth mentioning because of where it sits. NASA has a spacecraft called the Parker Solar Probe. It is a small heat-shielded machine that flies closer to the Sun than anything humanity has ever built. It dives again and again into the searing region near our star to study it up close. In December of 2025, from that fierce bright vantage, it too turned to look at the interstellar comet, an object made to study the youngest, hottest thing in our neighbourhood, pausing to observe the oldest, coldest visitor ever to pass through. There is a symmetry in that which I find hard to shake. The newest fire and the oldest ice, briefly in the same frame, and notice how many eyes were turned toward it, all at once. A survey in Chile found it. A planet hunter in space had already recorded it. A telescope in Israel had caught it early. Space telescopes studied its chemistry. A spacecraft at Mars photographed it. A spacecraft bound for Jupiter watched it go by. A probe diving toward the Sun looked back at it. For a few short months, a small dark hill from another star became one of the most watched objects in the sky. Machines scattered across the whole inner solar system tracked it. Each one turned to catch a glimpse of a traveller that would never come again. And it, of course, noticed none of it. It simply fell along its path, indifferent, silent, exactly as it had for billions of years. And then, having rounded the Sun, it began to leave. In the middle of March in 2026, it passed near Jupiter, within about 0.358 astronomical units, which is roughly 54 million miles. And Jupiter too has a watcher on the way, a European spacecraft called JUICE, bound for Jupiter's icy moons, was travelling through that region and turned to observe the comet as it went by. From that vantage, astronomers could see the comet's tail of gas stretching out behind it, a faint plume reaching across roughly 3 million miles of empty space, a thin banner trailing off an object that was already on its way out the door. That tail deserves a moment of its own, because it is easy to say the word tail and not feel it. A comet's tail is not solid. It is not a streak painted on the sky. It is gas, unimaginably thin, thinner than the best vacuum any laboratory on Earth can make, and yet stretched across millions of miles, glowing faintly where sunlight touches it. When this comet had a tail, it was a plume of material boiling off a frozen body, a body that had been sealed in the dark since before the sun existed. It unspooled now into a banner longer than the distance from here to many planets, a wisp so faint you could pass your hand through it and feel nothing, and so long it would dwarf whole worlds. That is the strange arithmetic of comets. Almost nothing, spread across almost everything. And that brings us to now, to tonight. Tonight, as you lie here, it is real and present and moving. Because this is the part that makes the title true. As you lie here, the comet is real and present and moving. As of the middle of 2026, it sits in the constellation Gemini as seen from our sky. It is roughly 600 million miles from the Sun. That is around 6.5 times the distance from the Earth to the Sun, well beyond the orbit of Jupiter. It is fading, it is cooling, and it is outbound, gathering speed on the long fall back into the dark between the stars. There is a detail about the way it moves that is worth pausing on, because it is quietly wrong in a way that unsettled the astronomers who study these things. This comet travels backward. Its orbit is what is called retrograde, meaning it runs against the grain, opposite to the direction the planets circle the Sun. Picture the planets as runners on a track, all going the same way, round and round, in the same patient direction they have kept for billions of years. And then picture one runner coming the other way, against the flow, cutting across the lanes at an angle, owing nothing to the pattern the others keep. That is this comet. It never joined the family, so it never learned the family's habits. It kept the direction it was given long ago, in another system, and it carried that direction here unchanged. And it is steeply tilted. It arrives not from the flat plane where the planets live, but from far to the side, coming up out of the southern sky near the constellation Sagittarius. The models that predict where interstellar visitors should come from had expected most of them to arrive from a different direction entirely. This one came from the wrong way, against the traffic, out of the deep south of the sky, as if to remind everyone that it owed our expectations nothing. No one predicts the sky quite right when a true stranger is involved. It came from where it came from, and it went where it went, and our neat model simply had to widen to make room for it. Here is the thing about its speed that I find hardest to hold in my mind. I want to offer it to you gently, as something to turn over as you drift. When it leaves, it will be moving at almost exactly the speed it had when it arrived. The Sun bent its path. The Sun could not keep it. Think of all that mass, all that gravity, the thing that holds 9 planets and countless moons and a belt of asteroids and a vast cloud of comets in its grip. And it could only nudge this traveller, curve its road a little, and let it go. It came in fast and it leaves just as fast. The Sun was a bend in the road, nothing more. And now think about where the road leads, because this is where the scale of the thing becomes almost too large to feel. It is heading out. Not around, out. Astronomers have projected its future path, and it reads like a slow disappearance. Around the year 2189, more than a century and a half from now, it will reach the inner edge of the Oort Cloud. That is the vast shell of icy bodies that surrounds our solar system, at a distance of about 2,000 astronomical units. And then it keeps going. In roughly 8,000 years, it will reach the outer edge of that cloud, 100,000 times the distance from the Earth to the Sun, and pass beyond it. And after that, it is simply gone. Back into true interstellar space, back into the dark it came from, essentially forever. Let those timescales land slowly. The year 2189 is more than a century and a half away, and yet on this comet's clock it is barely the first step out the door. 8,000 years to reach the outer edge of the Oort Cloud, and 8,000 years is longer than the whole of human history, longer than farming, longer than writing, longer than the wheel, and even that is only the edge of our own solar system. Past it lies the true void, the interstellar dark. The distances there are so great that the comet will drift for millions of years before it comes near another star. If it ever does at all, everything we have built, every word we have written, every life that will ever be lived on this planet will have come and gone many times over, and still this traveller will not have reached even the outermost fence of our own sun's territory. It is that slow, it is that far, it is that patient. Try to hold two facts together at once, softly, without straining. The first is that it will never come this close to a star again for an unimaginable stretch of time, possibly ever. The second is that no human alive tonight, and none of their children, and none of their children's children for thousands of generations will ever see it return. It came once. It is leaving. And the door is closing behind it slowly, over centuries, but it is closing. There is something almost tender in that, if you let yourself feel it. This thing drifted alone through the dark for billions of years, and for a brief window, a handful of months, it came into the warmth and the light of a star. It felt heat for the first time in eons. It grew a tail. It was seen and named and studied and wondered about by a species of small creatures on the third planet. And then it went back out, carrying nothing of us with it, remembering nothing, on its way to more dark and more silence and more time than we can count. You are witnessing the middle of a journey whose beginning was before the sun and whose end is beyond the reach of any calendar. And you are witnessing it from a bed, warm, safe, drifting toward sleep. There is no better place from which to consider something this large. Tonight you are exactly where you need to be to hold a thought this big without any weight at all. Let the path go now. Let the dates and the distances dissolve. What comes next is the thing itself. Close up, the strange chemistry it carries, the recipe it was built from, the fingerprints it wears. Because before we can talk about how old it is, we have to talk about what it is made of. And what it is made of is unlike anything we have ever measured before. So come closer to it in your mind and let us look at the body of this traveller. Tonight we're going to take it apart, gently, the way scientists did, and see what an object older than the sun is actually made of. Start with its size, because size is the thing everyone wants to know first, and it is the thing that is hardest to pin down. The Hubble Space Telescope first turned toward it in July of 2025 and studied it more carefully in August. Astronomers were trying to measure the solid core at the heart of the comet, the nucleus. But there is a problem that gets in the way of measuring any active comet. The nucleus is wrapped in a cloud of gas and dust, a glowing veil, and that veil hides the solid body inside it. So Hubble could only set limits. The nucleus was somewhere between about 1,400 feet, across at the smallest and 3.5 miles across at the largest. A wide range, because the veil is thick. But there is another way to weigh a comet, and it is a beautiful piece of reasoning, so let me walk you through it slowly. When a comet is warmed by the sun, it vents gas, and that venting acts like a tiny engine. It pushes. Not much, but enough to shove the comet very slightly off the path that gravity alone would carve. Astronomers can measure that little shove with great precision, and here is the elegant part. A small, light nucleus gets pushed more by the same amount of venting. Think of how a small boat is moved more easily than a large one by the same gust of wind. A large, heavy nucleus barely budges, so by measuring exactly how far the comet was nudged off course, they could work backward to its true size. That method points to something small, a nucleus somewhere between about 1/3 of a mile and 1/2 a mile across, well under a mile most likely, comparable in size to the second interstellar object we ever found. Small enough that many mountains on Earth would tower over it, This is not a world. It is not even a proper moon. It is a chunk of frozen material no larger than a modest hill, and yet it is old enough to have watched the sun be born. There is a wide disagreement buried in those numbers, and it is worth naming. Depending on which method you trust, the estimates of its true width differ by as much as a factor of 10. The dust that veils it will not lift, so no telescope has managed a clean, direct look at the solid body underneath. We are measuring a thing we cannot quite see, inferring its size from the way it moves and the way it shines, and the honest answer is that we do not know its exact size, only that it is small, probably under a mile, a hill dressed in a cloud. From that same careful measurement of the nudge, astronomers could estimate its mass, roughly 97 billion pounds. That sounds enormous until you realise how it is spread out. This is a hill-sized lump of ice and rock, ancient beyond reckoning. It weighs about as much as a large mountain, and it fits, in your imagination, inside the boundaries of a single city. Picture a single dark hill, older than the sun, small enough to walk across before nightfall. It is heavy only in the way a mountain is heavy, which is to say heavy, and yet nothing at all against the scale of a star. Now here is where it stops being an ordinary comet and starts becoming a genuine puzzle, because when astronomers looked at what it was breathing out, they found a recipe no one had seen before. Most comets are, at heart, dirty snowballs. Their activity is dominated by water. When the sun warms them, water ice turns straight to vapour, and that water vapour carries dust with it, and forms the glowing coma and the tail. Water is the engine of nearly every comet humans have ever studied up close. It is the default. It is the norm. This comet is not running on water. When the James Webb Space Telescope, our finest infrared eye, studied its gas in August of 2025, it found the coma dominated not by water, but by carbon dioxide. Dry ice, essentially, and not by a little. The ratio of carbon dioxide to water was around 8:1. 8 parts carbon dioxide for every 1 part water. That is one of the highest such ratios ever recorded in any comet. Anywhere. Ever. It is a dramatic break from the pattern. It is as if you had studied 1,000 loaves of bread, all made from roughly the same recipe, and then you found one loaf built from something else entirely, following instructions written in a different kitchen. There are competing ideas about why. It might be that the nucleus is simply, genuinely rich in carbon dioxide. It may have formed in a place so cold and so far from its parent star that carbon dioxide ice was abundant when it came together. Or it might be that a crust has formed over the surface, an insulating shell that traps the water ice underneath, while letting the more volatile gases slip out through it. Both of these remain live possibilities. The scientists who study it hold both in their hands at once, unwilling to close the question before the evidence closes it for them, and that honesty is worth admiring. Not knowing and saying so is its own kind of rigour. But sit with the first possibility, because it carries the deeper story. Around every young star there are invisible boundaries called frost lines, distances from the star where it becomes cold enough for a particular substance to freeze solid. Close in, where it is warm, only rock and metal can survive. Move outward, past the water frost line, and water can freeze into ice. Move further still, out into the deep cold. Out there, even carbon dioxide and carbon monoxide finally freeze into ice. Those are substances that stay gassy through the bitter cold of our own outer solar system. If this comet is genuinely rich in frozen carbon dioxide, then it formed far out past that distant frost line. It came together in the coldest reaches of its parent system, where only the most stubborn substances could freeze. It was assembled in the deep freeze of a solar system, in the outer dark, and then thrown from there into the deeper dark still. It has been cold its entire existence. The few months near our sun were the only warmth it ever knew. Whatever the reason, the numbers are vivid. In those August measurements, the comet was venting carbon dioxide at around 280 pounds every second. It was releasing carbon monoxide at around 30 pounds a second. Water came off at a comparatively modest 15 pounds a second. And there were traces of other things, including a sulfur-bearing gas called carbonyl sulfide. Later, after the comet had rounded the Sun, methane appeared as well. That showed up in follow-up observations near the end of 2025. A whole chemistry set, boiling off a frozen hill in the empty dark beyond Mars. Think about what that actually means, quietly, without doing the arithmetic. Every single second, hundreds of pounds of ancient frozen gas were lifting off this small body and streaming away into space. That gas had been locked solid for billions of years. It had never once been warm. It was released for the first and only time by the light of a star it long outdated. It was, in a very real sense, exhaling, a breath held for the entire age of our solar system, and longer let go at last in the warmth of our sun, and then gone. Then came the detail that made even seasoned astronomers pause: the nickel. In late July of 2025, a telescope in Chile, the Very Large Telescope, detected the fingerprint of nickel vapor coming off the comet. Nickel is a metal. Finding metal vapor around a comet is unusual but not unheard of. What made this strange was what came with it, which is to say, nothing. There was nickel and there was no iron. You need to understand why that is odd. Iron and nickel are cosmic siblings. They are forged together in the hearts of dying stars in the same violent furnaces. They are almost always found together, locked into the same minerals, and they are released together when those minerals are heated. Comets that give off nickel give off iron too. That is simply how it works. Every comet we know follows that rule. This one broke it. Nickel and no matching iron. Nickel walking out the door alone, leaving its sibling behind. There is a proposed explanation, and it is one of the strangest ideas in this entire story. Let me give it to you carefully, and let me be clear that it is not confirmed. The idea is that the nickel is being carried out not as plain metal, but locked inside a fragile compound called nickel tetracarbonyl. This is a highly volatile substance, a marriage of nickel and carbon monoxide that falls apart easily under sunlight. When it breaks down, it releases the nickel and the carbon monoxide and leaves iron entirely out of the equation. On Earth, this exact chemistry shows up in industrial nickel refining, in factories, under careful human control. Now imagine the same process happening on this comet, by nature, on its own, in the cold and the dark. If it is real, it is something that has never once been documented in any natural comet in all the history of the field. Sit with that image for a moment as you drift. A chemistry we associate with metal refineries, with human industry, appearing by pure accident in the coma of an object older than the Sun. Not because anyone built it, not because anything intended it, just because the ingredients happened to be there, and the sunlight happened to be enough, and physics did what physics does. It is almost certainly a natural process, and it is almost certainly one we have never seen nature perform before. The strangeness does not stop there. This comet is oddly empty of things that most comets carry. In a typical comet, sunlight breaks apart the parent molecules into a familiar set of fragments. Among the most common are pairs and chains of carbon atoms. Chemists label them C2 and C3, dicarbon and tricarbon. They are so reliable that their absence is notable, and in this comet they are largely absent. So is atomic oxygen. So are certain nitrogen-bearing fragments that usually show up. This is one of the most carbon chain depleted comets ever measured, another way in which it simply does not match the family we know. Now, let me give you a sense of scale for the cloud it wears, because the numbers here are genuinely hard to feel. The visible coma, the glowing veil of gas and dust you could in principle see, measured something like 16,000 miles across, already twice the width of the Earth. But that is only the part that shines in visible light. When astronomers looked in the infrared at the invisible cloud of carbon dioxide gas surrounding the nucleus, they found it stretching out to a radius of at least 216,000 miles, which is roughly 90% of the distance from the Earth to the Moon. Hold that picture. A frozen hill, no more than half a mile across, sitting at the centre of an invisible breath of gas that reaches nearly all the way to where the Moon would be. If you stood on the nucleus and could somehow see that gas, it would fill your entire sky and keep going. It would reach out past where our Moon hangs in our own sky, a cloud almost as wide as the space between the Earth and the Moon, wrapped around a body you could walk across in an afternoon. The thing itself is tiny. Its presence is vast. The dust it sheds has a colour too, and the colour tells a story. It is reddish, deep reddish, similar to the darkest and most primitive asteroids in our own solar system, the ones that have been sun-baked and space-weathered and left largely untouched since the beginning. That red is the colour of long exposure, of eons of cosmic radiation slowly working on a surface. It is the hue of a thing that has been out in the cold and the dark for so long that it has taken on the colour of ancient unwashed stone. For a while, in the earliest weeks, its dust behaved strangely too. The plume came off the sunward side of the nucleus, the side facing the sun rather than trailing behind, as if the comet were exhaling toward the light rather than away from it. Only later, by the end of August, did it settle into the more familiar pattern. It grew a proper tail that trailed away from the sun. That tail reached some 35,000 miles by the end of the month, and it stretched further still into September, past 60,000 miles by the middle of the month. The dust itself came in two kinds, and the balance of them tells a small story. There were fine particles, small grains only a few thousandths of an inch across, streaming off at a modest rate, and there were larger particles, coarser grains, coming off in far greater quantity, 10 times the mass or more. So the comet was shedding a mix, a fine haze and a heavier fall, like a slope giving up both its dust and its gravel at once. Astronomers even measured the way that dust bent and scattered light, a technique called polarimetry. They found it behaving unusually. The pattern suggested a coma mixed of icy grains and dark material, unlike most of the comets born in our own cold outer reaches. Even in the smallest details, in the way its dust caught the light, it refused to look quite like home. And through all of it, through the intense heat of its closest approach, through the fierce warming that has torn other comets apart, this one held together. No fragmentation, no sudden outburst, no breaking. It simply endured, venting its strange breath, steady and stable, an old traveller that had seen worse than a single star's heat, and was not about to come apart now. There is one more thing worth marvelling at before we move on, and it is how much we have learned about this object without ever touching it. We have never landed on it. We have never flown a spacecraft alongside it. No probe has scraped its surface or sampled its gas directly. Everything we know, we learned from its light, from the faint glow of its coma spread out into its colours, red for the fingerprints of the elements it carries. That is the quiet magic of the whole thing, a wisp of light from an object smaller than a mountain, hundreds of millions of miles away, moving faster than almost anything we have ever tracked. And from that thread of light alone, we have measured its size and weighed it. We have mapped its gases, counted its isotopes, and read its impossible age. It never came near us. It never will again. And still we know its story, written entirely in the language of a light. You can let those numbers dissolve too, the ratios and the rates and the miles. What I want to leave you with is the feeling of the thing. A small, dark, red, ancient body, breathing out a chemistry no one has ever catalogued, wearing a cloud of invisible gas nearly as wide as the gap to the moon, holding itself together through the fire of a star it long outdates. It is a chemistry set from another kitchen, and every strange thing about it is a clue pointing back toward the one question we have not yet answered. How old is it really? And how could anyone possibly know? That is where we are going next, and it is the heart of the whole story. But before we read its birth certificate, I want to pause just briefly, because this is the one moment in tonight's journey where I will ask something small of you. If you're drifting off to the sound of this, and you find that these long, slow walks through the dark help quiet your mind, at the end of the day, you can follow along on Spotify. That is where these journeys are gathered together for exactly nights like this one. That is all. You do not need to do anything now. Stay where you are, stay soft, and let us return to the traveller and the impossible question of its age. Because here is the difficulty. This object carries no label. There is no date stamped on its side. There is no ring you can count, no layer you can peel, no fossil tucked inside it with a known age. It arrived out of the dark with no identification at all, and yet a handful of scientists have looked at it and concluded, carefully, with real evidence, that it is very likely older than the Sun. So the question is not just how old. The question is how on earth anyone could tell. The answer comes in two parts, from two very different kinds of evidence, and they point remarkably in the same direction. Tonight we're going to walk through both of them slowly. By the time you drift off, you will understand exactly how a birthday gets read from a thing with no birth certificate at all. The first kind of evidence is about motion, about the way the comet moves through the galaxy, and where in the galaxy that motion places its home. To follow this, you need to know one thing about our galaxy that is easy to picture. The Milky Way is not a uniform blur of stars, it is layered. There is a thin disk, a flat, bright plane where most of the stars live, including our own Sun. The stars there tend to be younger, on average somewhere in the range of a few billion years. They move in relatively calm circular orbits, close to the flat plane of the galaxy, and then there is a thick disk, a puffier, older layer, above and below the thin one, made of stars that formed early in the galaxy's history, in its rougher, more violent youth. Those stars are old, generally well over 7 or 8 billion years, and they move differently. They wander further above and below the plane. They ride on more disturbed, more restless orbits, the orbits of an older, wilder time. Picture the galaxy for a moment as a great flat plate of light seen edge on. Most of the stars, and our own Sun among them, ride in the thin bright line of the plate, the calm sheet where the newer generations were born. But wrapped around that bright line, above it and below it, is a fainter, puffier haze. It is an older cloud of stars that were already ancient when the thin disk was still forming. That haze is the thick disk. It is the galaxy's first draft, its rougher early handwriting, written before the neat straight lines came later. And the stars in it do not sit still in the plane. They swing up and out of it and fall back through, on long looping paths. That is the way an old thing moves when it has been in motion far longer than everything around it. So when astronomers watch how an object rises and falls out of the galactic plane, they are in a sense watching how old its habits are. And this comet has the habits of the old population. So if you can measure how a lonely object like this comet is moving through the galaxy, you can ask which layer it seems to belong to. And the way it moves matters enormously, because a thick disk object is, almost by definition, ancient. When astronomers measured this comet's motion, they found it moving in a way that fits the thick disk. It has an unusually high vertical velocity, meaning it is bobbing up and down out of the galactic plane more than a young thin disk object would. And its motion relative to the Sun, once you account for the Sun's own path through the galaxy, has the restless, elevated character of the old population. None of this proves by itself where it was born, but it is exactly the kind of motion you would expect from something ancient, something that formed early, something that has been riding the galaxy's older currents for a very long time. A team centred at the University of Oxford took this reasoning and built it into something powerful. The work was led by a young researcher named Matthew Hopkins. And here is a detail almost too fitting to believe. He had defended his doctoral thesis on exactly this kind of object just 1 week before this comet was discovered. He spent years preparing a model for interstellar visitors that did not yet exist. And then, 7 days after he finished, one arrived. He worked with his colleague Chris Lintott and collaborators at a university in New Zealand. Together they combined data from a European star mapping mission called Gaia. Gaia charts the positions and motions and ages of stars across the galaxy. They matched that data against models of how planet-forming disks are built and how the galaxy stirs its contents over time. Out of that model came a number, and I want to give it to you exactly as they framed it, with all its honest uncertainty intact. They estimated a roughly 2/3 probability that this comet is older than the solar system. Their best single estimate came out around 7 billion years, and if it truly belongs to the thick disk, the range could run as wide as 7.5 to 14 billion years. Let those numbers breathe for a moment. 7 billion years. The Sun is about 4.6 billion years old. So if the best estimate holds, this object was already roughly 2.5 billion years old when our Sun began. It was already an ancient wanderer while the cloud of gas that became our Sun had not yet begun to collapse. And the upper end of that range, 14 billion years, brushes right up against the age of the universe itself, which is about 13.8 billion years. That upper edge is unlikely. But the fact that it is even in the range tells you what kind of object we're dealing with. Try to feel the length of 7 billion years if you can. The truth is that no one really can. A human life is less than 100 years. Everything people have ever set down in writing, the whole long record of kingdoms and songs and wars and quiet lives, fits inside about 5,000 years. The pyramids are less than 5,000 years old. The oldest cave paintings go back a few tens of thousands. The first modern humans, a couple of 100,000 years. The dinosaurs died out 66 million years ago. That already feels like a number too large to hold. Now take that number, 66 million, and multiply it by more than 100. That is how far back 7 billion years reaches. This comet is older than the ground under every city. It is older than the oldest rock a geologist has ever found. It is older than the Earth itself. It is older than the Sun. It formed and drifted loose and began its journey through the dark. And all of that happened before the material that would become your planet had even started to gather. And here is the part that goes deepest. If the age is right, the star this comet formed around is almost certainly gone. Stars do not live forever. The older and more massive they are, the sooner they burn through their fuel. They swell up, they shed their outer layers, and they fade to a cooling ember, or collapse into something small and dense and dark. A star old enough to have made this comet has very likely finished its life long ago. So this frozen fragment may be the last surviving piece of a solar system that no longer exists. An orphan, in the most literal sense. Its sun is dead. Its sibling planets, if it had any, are cold and dark or long since scattered. And it alone, this one small hill of ancient ice, carried the chemistry of that lost place. It carried it unchanged, across the whole width of the galaxy and the whole depth of time, to be seen for a few months by us, and then to vanish again. It is a message with no sender left alive. Chris Lintott put it plainly. He said there is a 2/3 chance this comet is older than the solar system, and that it has been drifting through interstellar space ever since. Ever since. Since before there was a sun, since before there was an Earth. Drifting the whole time through the cold and the dark, alone. There is something I want you to hold about that phrase, 2/3 probability. It is easy to hear it and round it up to certainty. It is just as easy to dismiss it as a guess. It is neither. 2/3 probability means this. Imagine you could line up a great many objects exactly like this one, arriving on paths exactly like this one, moving through the galaxy exactly as this one moves. About 2 out of every 3 of them would turn out to be older than the Sun. It is a statement about the odds, made carefully with the evidence laid out. It is not a coin flip, and it is not a certainty. It is the honest shape of what we can know about a thing that carries no label. And the remaining 1/3 the chance that it is somewhat younger, belonging to the galaxy's newer layer after all, is kept openly on the table, not hidden away. That is what good science looks like when it is being honest about what it does not know. Now, I promised you honesty, and honesty means telling you that this is not the only estimate. These are not measurements in the way that weighing a thing on a scale is a measurement. They are inferences. Careful, disciplined, evidence-based inferences, but inferences all the same. Around the same time, a separate pair of researchers, working independently with different assumptions, ran their own analysis and arrived at a different but overlapping range. They put its age somewhere between roughly 3 and 11 billion years. That range still leaves plenty of room for the comet to be older than the Sun. But it is not the same as the Oxford number, and the difference matters. It tells you that we are looking at a probability, a spread of possibilities, not a single settled birthday. No one is claiming to have found a candle count on this comet's cake. They are reading the odds, from the way it moves and the company it seems to keep. And then, in the middle of 2026, came the second kind of evidence, the stronger kind, the kind that does not depend on statistics about the galaxy's layers at all, but instead reads the object's own chemistry directly. And this is the anchor of the whole case, so let me give it to you slowly. The idea rests on something called isotopes. Here is what that means, in plain terms. The atoms that make up ordinary matter come in slightly different weights. Carbon, for instance, is almost always the light version, carbon-12, but a small fraction of any batch of carbon is the slightly heavier carbon-13. Same element, same chemistry, just a touch heavier. The same is true for nitrogen. There is a common light version and a rarer heavy one. And here is the crucial fact. The exact ratio of light to heavy, the proportion of ordinary carbon to heavy carbon, is set by where and when and how a batch of material formed. Different environments, different temperatures, different eras of the galaxy, they all leave a different ratio behind. That ratio is a fingerprint. It is stamped into the material at its birth, and it does not wash off. Read the ratio, and you are reading the conditions of the place and the age it was made. Every comet in our own solar system was made from the same original cloud of material, the cloud that became the Sun and the planets. So every one of them carries roughly the same isotopic fingerprint within a known range. It is a family signature. Measure the carbon and nitrogen ratios of any solar system comet, and they fall inside a band we know well. In 2026, a team led by an astronomer named Cyrielle Opitom set out to measure exactly these ratios. She works at the University of Edinburgh with colleagues in Belgium and Finland. They used the Very Large Telescope in Chile to read the ratios in this comet's gas, specifically in a molecule called cyanide, which the comet was venting, and which carries both carbon and nitrogen atoms whose isotopes can be read. What they found is the strongest single piece of evidence in this whole story. The carbon ratio came out around 147. In our solar system, that ratio sits around 90. The nitrogen ratio came out around 343. In our solar system, it sits somewhere between roughly 130 and 170. Both numbers, carbon and nitrogen, fell completely outside the range of every comet ever measured in our solar system. Not at the edge of the range, not unusually high, but still within it. Outside it, beyond it. In territory no comet from our own family has ever occupied. That is the fingerprint of a stranger. Not a stranger who moved in from a slightly different neighbourhood. This is a stranger built from material assembled somewhere else entirely, under different conditions, around a different star, at a different time in the history of the galaxy. The chemistry says, plainly and without appeal to any statistical model of the galaxy's layers, this was not made here. This was made far away and long ago. And this is why the isotope work is the strongest evidence of all, stronger than the way it moves, stronger than the statistics of galactic layers. Motion can be argued about. Orbits can be reproduced by more than one history. But the isotopes are written into the material itself, at the moment of its making, and they cannot be faked and cannot be scrubbed. They are the closest thing this object has to a birth certificate, and the certificate is not smudged or ambiguous. It reads, "In a chemistry we can measure but cannot reproduce here at home, made elsewhere." There is no room in those numbers for the object to be one of ours that simply wandered off. The material is foreign. The recipe is foreign. The kitchen it came out of closed billions of years ago and lies somewhere across the galaxy that we will never find. There is a reason older stars leave a different chemical signature, and it is worth understanding because it ties the whole case together. When the universe was young, it was made almost entirely of the two lightest elements, hydrogen and helium, and very little else. The heavier elements, carbon, nitrogen, oxygen, iron, nickel, all the richer ingredients did not exist yet in any quantity. They had to be manufactured, forged in the hearts of stars and scattered into space when those stars died. So each new generation of stars is born from gas a little richer in heavy elements than the generation before. The galaxy slowly seasons itself over billions of years, star by star, death by death. Which means that a star poor in heavy elements is almost always an old star, born early, before the galaxy had done much of its cooking, and every sign points to this comet forming around exactly such a star, a metal-poor star, an old star, a star from the galaxy's early leaner years. Oppitom described the object beautifully. She called it a chance to probe the composition of another planetary system, one that formed long before our Sun, a fossil, in effect, from a planet-forming process that happened very far away and very long ago. That word, fossil, is worth holding, because a fossil is a thing that outlived its world, and this comet may have outlived not just its world, but its very star. The sun it formed around may have died billions of years ago. It swelled and shed its outer layers and faded to an ember. And all the while this small frozen fragment sailed on through the dark, carrying its birthplace's chemistry unchanged, a fossil of a solar system that no longer exists. And that isotope work does not stand alone. It is backed up by other measurements pointing the same way. Separate studies, using different telescopes, found that the comet's gas is enriched in a heavy form of hydrogen called deuterium. Heavy hydrogen builds up preferentially in colder, more distant, more primitive environments. Finding more of it than usual is another independent signature of formation in a cold, far-off place, older and more pristine than the region where our own planets came together. Two different chemical fingerprints, read by different teams with different instruments, both saying the same thing. Made somewhere colder, made somewhere older, made around a star that had fewer of the heavy elements our Sun enjoys, and that is itself the mark of an older star. Those heavy elements only accumulate in the galaxy slowly, over generations, as star after star forges them and scatters them into the dark. Put it all together, and the picture converges. The way it moves through the galaxy suggests the old thick disk population. The isotopes in its gas fall outside anything our solar system produces and point to a cold, distant, metal-poor birthplace, and the deuterium backs that up. Several kinds of evidence from several directions, all leaning the same way. Older than the Sun, possibly much older. Some of the reporting on the isotope work describes it as more than twice as old as the Sun. It raises the possibility of an age reaching toward 12 billion years. That edges up toward the age of the universe itself. This is how a conclusion earns its confidence in science, not from a single dramatic measurement. It comes from many separate lines of evidence, gathered by different people, with different instruments, under different assumptions, and they all happen to point at the same answer. The way it moves did not know what the isotopes would say. The isotopes did not know what the deuterium would show, and yet all of them independently arrived at the same place. Old, foreign, made long ago, far away, around a lean and ancient star. When several roads that never spoke to each other lead to the same door, you begin to trust the door. That is where this stands, not proven to the last decimal, not stamped with an exact birthday, but pointed at from every side, by evidence that agrees, and what all of it agrees on is the one thing the title promises. This object is, in all likelihood, older than the Sun. I want to be careful and fair here, because this is the place where it would be easy to overreach, and you deserve better than that as you fall asleep. The exact age is not a fixed number, it is a spread. 7 billion years is the best single estimate from one team, 3 to 11 billion from another, up toward 12 billion from the newest chemical work. These ranges overlap, and they all agree on the essential thing. It is probably older than the Sun, but they are not identical, and every team that produced them has been careful to call them estimates, not certainties. And there is one more limit worth being honest about. No one can trace this comet home. No one can point to the star it was born around. Because over billions of years the galaxy stirs everything. Stars drift, orbits shift, the whole slow churn of the Milky Way erases any trail. So we can read the era and the conditions of its birth, but we cannot find its birthplace. It is like reading from the chemistry of a person's bones that they were born in a cold country in a distant century, without ever being able to name the town. The biography is real, the address is lost forever, but hold the essential thing, because it survives all the uncertainty. Whatever the exact figure, this object was already old, already drifting, already alone, before our sun caught fire. It watched, if watching is even the word, from the outside, the whole story of our solar system unfold. It was there, out in the dark, when the sun ignited. It was there when the earth cooled. It was there when the first life stirred and the first fish crawled and the first tree grew and the first human looked up. It carried its ancient chemistry through all of it, unchanged, indifferent, until one night a machine in Chile caught it crossing a field of stars. That is not a number, that is a fact you can feel, and it is enough to make you very small and very calm at the same time. Let the age rest there now. Tonight we're going to leave the numbers where they are, uncertain and honest, and simply hold the shape of what they tell us. We have read its birth certificate as well as it can be read. What remains is to understand how a thing like this gets loose in the first place, how a comet gets thrown out of its home and sent wandering. We will meet the two strangers that came before it, and we will face briefly and fairly the loudest and strangest claim anyone has made about it. So let us ask the simple question: how does a comet end up homeless, cast out into the dark between the stars, with no star to call its own? Tonight we're going to answer that, and then meet the only two visitors like it that humanity has ever seen. The answer is violence, though a slow and gravitational kind of violence. Every star system when it is young is a chaotic place. The planets have not yet settled into their calm, stable orbits. The giants, the Jupiter-sized worlds, are still shifting, still migrating, still throwing their weight around, and out among them are countless smaller bodies, comets and icy fragments, the leftover crumbs of planet building. When one of those small icy bodies drifts too close to a giant planet, the giant's gravity grabs it and flings it. Picture a marble rolling slowly across a table, and then a much larger marble comes crashing past. The small one is knocked hard, sent careening away. If the giant planet's shove is strong enough, the little body is flung clean out of the system entirely, not just into a new orbit, but away for good, faster than the star's gravity can ever pull it back. It becomes an exile. It leaves its star behind forever and begins to drift. That is almost certainly how this comet was made homeless. Some giant planet, around some ancient star billions of years ago, caught this small frozen body in the chaos of that system's youth. And it threw it out into the night, and then began the longest part of its story. The drifting, not for years, not for millions of years, for billions. Alone, in a cold so deep and a dark so complete that our imaginations simply slide off it. This thing fell through the space between the stars. Try, gently, to imagine that drift. Again, the truth is that no one really can. Imagine the moment of the throw. The last time this object was warm. The last time it was near a star. It swung past that giant planet and was flung outward, faster and faster. The star it was born to shrank behind it, to a single point of light among many, and then to nothing at all, indistinguishable from the rest. And then, silence. No sunrise, no seasons, no day and no night, just the deep cold of interstellar space, only a few degrees above the coldest temperature that can exist. Just the slow, patient dark. Just the stars turning past at unthinkable distances, none of them close enough to warm it. For 1 billion years, and then another still. Longer than the Earth has existed. Longer than the Sun has existed. A journey so long that when it began, our solar system was not even a cloud yet. And by the time it ended, we had built cities and telescopes, and were waiting, without knowing it, to catch its light. Along the way, it did not stay entirely apart from the galaxy's other residents. One study traced its long, looping path. In just the last 10 million years, a mere sliver of its life, it may have passed within a few light years of as many as 25 known stars passed near them, never captured, never held. It threaded between them like a needle through cloth, close enough to feel their gravity tug, never close enough to be caught. And it moved on, always on, deeper into its journey, until at last it fell toward a small yellow star with a blue planet and was seen. And that is only the last 10 million years, which is nothing at all against its full age. 10 million years is the blink before the blink. If it is 7 billion years old, then that trace stretch of its path, those 25 near passes, covers barely more than 1,000th of its life. The rest is unrecorded and unrecoverable, lost to the churn of the galaxy, billions of years of drifting that we can never reconstruct. It passed near stars that have since died. It crossed regions of the galaxy that have since been rearranged. It saw, if seeing is the word, an entire history of the Milky Way that no telescope will ever show us, because the evidence of it has been stirred away. We've caught it at the very end of a journey whose beginning and whose middle are simply gone, erased by time, unknowable. We get the last chapter. The rest of the book is dust. And the models tell us it is not alone in being alone. The Milky Way, according to the mathematics, should be full of these exiles. Billions upon billions of them, cast out of their birth systems, drifting essentially forever between the stars. An entire population of homeless wanderers, filling the dark between every star with silent, frozen travellers. And yet, of all those billions, we have confirmed exactly 3. Which raises a question that hangs quietly over this whole subject. Are they truly rare, or have they simply been too faint, too fast and too dark for us to catch, until now? Here is a way to feel how thinly they are spread. The best current guess is that interstellar space holds only about one of these objects in each enormous volume of space, a volume roughly bounded by the distance from the Sun out past the planets, cubed. That sounds crowded until you realise how vast that volume is, and how empty. Between us and the nearest star there is room for an unthinkable number of such volumes, and in each one, at most, a single silent wanderer, drifting, never meeting another, never being seen. The dark is full of them, and yet the dark is so vast that they almost never touch anything. This one touched us. Out of all the billions on its one and only pass, it fell close enough to a small yellow star. And it did so in the brief window when that star's third planet had built the instruments to notice. So it was seen. The unlikeliness of that is its own kind of quiet miracle. Let me introduce you to the 2 that came before, because they could not have been more different from each other, or from this one. The first arrived in October of 2017, and it was found by an astronomer named Robert Verick. using a telescope in Hawaii. It was given a Hawaiian name, one that means, roughly, a messenger or a scout reaching out from the distant past. And it was strange from the very beginning. Think back to what those weeks were like. It was already leaving when it was found. That was the problem from the start. By the time anyone understood what it was days past its closest approach, already fading, already pulling away. So a scramble began. Telescopes around the world swung toward one faint, fast-moving speck. The clock was against every one of them. They had a handful of nights, maybe 2 weeks, before it slipped beyond reach. And the more they looked, the stranger it got. Its brightness swung wildly as it tumbled. That swing suggested a shape almost nobody expected. Long and thin, like a splinter or a shard turning end over end. No comet in our own solar system looks like that. Then came the second puzzle. As it left, it sped up. Just slightly, but more than gravity alone allowed. On any normal comet, venting gas explains that push. This one showed no gas, no tail, no cloud at all. The clock ran out before anyone could settle it. It faded past the reach of every telescope on Earth, and it took its answer with it, out into the dark, forever. We got one brief, blurred look at the first visitor, and then it was gone. It was highly elongated. Some estimates made it as much as 10 times longer than it was wide. That is a shape unlike almost anything in our own solar system, more like a splinter or a shard than a rounded rock. It was reddish. It tumbled as it went, turning over slowly, end over end, and it was fast, moving at something like 196,000 miles per hour. But the strangest thing about it was what it did not do. It did not grow a tail. It showed no visible coma, no cloud of gas, no dust. For an object we expected to be an icy comet, that silence was deeply odd. A comet that came that close to the sun should have started to boil. This one stayed dark and dry and quiet. Astronomers went back and forth on what to call it. First a comet, then an asteroid, and finally they simply invented a new category for it, because it fit nowhere else. The first interstellar object. And then it did one more strange thing. As it left, it sped up very slightly, more than the sun's gravity alone could explain. On a normal comet, that little extra push comes from venting gas. But this object showed no visible venting at all. It accelerated with no obvious engine. That single fact, a subtle push with no visible cause, has never been fully settled. Most astronomers believe the answer is some kind of gentle outgassing, too faint to see. Perhaps an unusual ice, such as frozen hydrogen, that leaves no glowing trace as it escapes. That is the natural explanation, and it is very likely the right one. It only ever needed a whisper of gas, too thin to see, to produce the push that was measured. But because the puzzle was never completely closed, because no one could point to the venting and say, there, that is it left a small door open, and through that door walked the most controversial idea in this entire subject. It is worth being fair about why that door stayed open at all. Science is honest about its loose ends. When an object accelerates, and you cannot see the cause, you do not simply declare the case closed and walk away. You write down that it is unexplained, and you keep it on the list of things not yet understood. That first visitor left with a small, genuine mystery attached to it, a mystery that has never been fully tied off. It was gone too quickly, discovered too late in its passage, for anyone to gather the observations that might have settled it. It slipped away carrying its secret, and it will never come back to answer the question. That, more than anything, is why it still haunts this subject. Not because the strange explanation is likely, but because the ordinary explanation was never quite nailed down, and the object that could have settled it is gone forever. A Harvard astronomer named Avi Loeb suggested that this first object might not be natural at all, that it might be artificial, a thin sail perhaps, built by some other civilization, catching sunlight the way a sail catches wind, which could explain the gentle push without any venting, It was a minority view. It remains a minority view, but it captured the public imagination in a way few scientific claims ever do. And it set the stage for what would be said about the object we are following tonight. Before we get there, meet the second visitor. It arrived in 2019, and its story is almost reassuring by comparison. It was found not by a great observatory, but by an amateur astronomer in Crimea named Gennady Borisov. He used a telescope he had built himself by hand with his own tools. One person, one homemade telescope, one interstellar comet. There is something wonderful in that. And this second visitor behaved beautifully. Ordinarily, almost politely, it had a proper coma. It had a proper tail. It released gas and dust the way a well-mannered comet should. Through a telescope it looked like a faint, fuzzy, green-tinted comet. The kind you might expect to find had drifted in from our own outer solar system. If the first visitor was a strange, dark splinter that broke every rule, the second was a familiar face from out of town. It behaved exactly as comets behave. It just happened to have come from another star. Studies did find it a little unusual in its chemistry. It was oddly short on those same carbon chain molecules. That is a quirk it would turn out to share with the object we're following tonight. And some evidence suggested its ices were remarkably pristine, perhaps never significantly warmed since the day it formed, until it fell past our sun. Some astronomers called it possibly the most pristine comet ever found. It was so untouched that its passage past our sun may have been the first warmth it had ever felt. But on the whole, it was the ordinary one, the one that looked like home. There is a lesson tucked inside that contrast, and it is a reassuring one, so let it settle in as you drift. The second visitor, the ordinary one, is proof that a comet from another star can look entirely familiar, entirely explainable, entirely at home in our own physics. It did not need any exotic story to make sense of it. It was strange only in where it came from, not in how it behaved. And that matters for how we think about the third one, the one passing tonight. Because it tells us that even a genuine interstellar traveller can be at heart just a comet, an ordinary process wearing an extraordinary origin. The strangeness of the third one, its carbon dioxide, its lonely nickel, its ancient isotopes, is real. But the second one reminds us that strange chemistry does not require strange explanations. Nature is wide enough to contain all of it. So consider the three of them together, the entire catalogue of interstellar visitors in all of human history. The first was a naked, tailless, tumbling splinter that behaved like nothing we knew. The second was a comfortingly ordinary comet that behaved almost exactly like one of our own. And the third, the one passing tonight, may be older than the sun itself. It breathes a chemistry no one has catalogued. It wears a cloud nearly as wide as the gap to the moon. 3 objects, 3 completely different characters. Every single time we have opened this door, the universe has shown us something we did not expect. No one expects the next one to be ordinary anymore. Which brings us at last to the loudest claim about this comet. And I want to handle it fairly. It is part of the story. You have surely heard some version of it. And the truth of it is more interesting than the noise around it. Tonight we're going to look at that claim squarely, and then set it gently in its place. The same Harvard astronomer, Avi Loeb, has argued that this comet too might be artificial. He has put a number on it, in his own public reasoning, of around a 40% chance that it is some kind of technology, rather than a natural object. He points to the same subtle non-gravitational push that other comets show. He points to the shape of its jets of gas, which he finds unusually well aligned. He points to its rarity, and to the odd angle of its arrival. He frames it, in his own words, as playing devil's advocate, as working through the probabilities out loud rather than making a confident declaration. And to be fair to the impulse behind it, there is something genuinely reasonable in the underlying instinct. If interstellar objects are now passing through often enough to be caught, then it is only sensible to check. Someone, somewhere, should at least ask whether any of them are more than rock and ice. It costs little to look. And so people did look, seriously, without embarrassment. Radio astronomers turned their great dishes toward the comet and listened patiently across many frequencies. They listened for any signal that might betray a made thing, a transmitter, a beacon, an accidental leak of communication. That is the responsible version of the question, asked properly, with instruments rather than assertions. It is a good question to ask. The answer simply came back empty. Now let me tell you where the rest of the field stands, because this is where you can rest easy. The overwhelming majority of astronomers who have studied this object classify it as a natural comet. Not a probable comet. A comet. Its coma, its gas chemistry, its dust, its behaviour around the sun, all of it fits, if unusually, within known cometary physics. The carbon dioxide, the nickel, the isotopes, the tail, the way it held together through perihelion. None of it requires an engineer. It requires only nature, working under conditions we have not encountered before. NASA classifies it as a natural comet. Even the branch of the Pentagon that watches for unexplained aerial phenomena has said, plainly, that it has no evidence of any extraterrestrial technology connected to this object. Radio astronomers pointed their instruments at it, listening for any signal, any transmission, any whisper of intent. They heard nothing, just the silence of an ancient rock venting gas on its way through. And many working scientists have been openly critical of the way the alien idea has been promoted. They argue that pushing it publicly, ahead of the evidence, does real harm. Harm both to public understanding and to the careful reputation that science depends on. Their frustration is understandable. Because here is the quiet irony at the centre of it. The natural explanation is not the boring one. The natural explanation is that this is a fragment of another solar system, older than our Sun. It formed around a dead star in an ancient corner of the galaxy. It has drifted alone through the dark for billions of years, and now it is passing us once, forever, breathing a chemistry we have never seen. If that is the disappointing answer, then we have set a very high bar for wonder. So here is how I would leave it gently as you drift. The idea that it is alien technology is a real thing that a real scientist has really said, and it is fair to know that. But it is a minority position, held by very few. It is contradicted by NASA and by nearly everyone who has looked closely. And it is unsupported by any evidence gathered so far. The story does not need it. The truth is stranger and calmer and larger than the claim. An old, dark, silent traveller, made of ice and metal and time, is passing through, and it is exactly what it appears to be, and that is more than enough. Let the controversy fall away now. It was only ever a small, loud thing at the edge of a very large, very quiet story. What remains is the traveller, and the dark it is returning to, and one last thought about what comes after it. Because this comet, as rare as it is, may be one of the last of its kind to feel truly rare. Tonight we're going to end where the whole story is heading, out past the edge of what is rare, into a future where visitors like this arrive again and again. Remember that brand new telescope in the Chilean mountains, the one that nearly discovered this comet and missed by 2 weeks. It has now begun its real work. For the next 10 years, it will photograph the entire visible sky, over and over every few nights, building the most complete moving record of the heavens ever made. It is designed for exactly this, to catch the faint, the fast, the fleeting, to notice the single point of light that was not there before and is gone again by morning. Let me tell you what that survey actually is, because it is worth understanding. It is called the Legacy Survey of Space and Time. At its heart sits the largest camera ever built for astronomy. The camera is roughly the size of a small car. Each single image it takes is so enormous that it would take hundreds of ordinary screens to show one at full detail. And the plan is simple and relentless. Point at a patch of sky. Take the picture, move on, come back a few nights later and take it again. Do that across the whole southern sky, over and over for 10 straight years. What you build in the end is a movie of the heavens. Not a still photograph, but a record of what moves. And a fast, faint visitor from another star is exactly the kind of thing that shows up in a movie and vanishes from a snapshot. So the arithmetic changes. What took a lucky accident to catch this year becomes something the survey is actively hunting. And if the estimates hold, it may find one of these interstellar wanderers every year or more. A thing that was once a headline may quietly become a routine. That is the shift we are standing at the edge of right now. And when a telescope like that goes looking for interstellar visitors, the mathematics say it should find them. Not one, ever, as a once-in-a-generation event. Many. The estimates vary widely, because we still do not know how densely these wanderers fill the dark. Some studies suggest a handful a year. Others suggest that in the most crowded case, it could find dozens in a single year. One older estimate went further still. If you counted even the very smallest objects, the ones no bigger than a house, this telescope might catch more than 100 of them every year. Though most would be far too faint to study in any real detail. The uncertainty is enormous. It comes down to one poorly known number. That is the true density of these exiles in interstellar space, a number we have only been able to guess at from the few we have caught. But every new detection sharpens that guess. And the direction is clear. It is worth pausing on how strange this shift really is, historically. For the entire span of human existence, from the first fire to the first spacecraft, we lived inside a solar system that seemed, as far as we could tell, sealed. Everything we saw in the sky belonged to us, or to the sun, or to the fixed and distant stars that never seemed to send us anything at all. The idea that physical objects from other star systems might drift into ours was once pure speculation. The thought that we might one day hold their light in a telescope and read their chemistry was the stuff of theory and imagination. And then, in the span of a single decade, it became fact 3 times over. We crossed, quietly, without ceremony, from a species that had never confirmed a visitor from another star to a species that studies them. That threshold, once crossed, does not get uncrossed. From here on, the dark between the stars is a place we know sends us things. There is a reason they are so hard to catch, and it is a lovely subtle one. These objects move so fast across the sky that their light smears. In a single exposure, while the shutter is open, they slide across several pixels, spreading their already faint glow even thinner, blurring themselves into the background noise. Astronomers call it trailing loss. It means these visitors are even harder to see than their faintness alone would suggest. They erase themselves a little, just by moving, which may be part of why we have found so few, not because they are rare, but because they are quick and quiet and easy to miss. So think about where this leaves us. Until the year 2017, in all of recorded history, humanity had never confirmed a single object from beyond our solar system. Then came the first, then the second, and now this third, the oldest and strangest of them. And within the coming decade, we may go from having studied 3 such objects across all of human history to studying several new ones every single year. A once-in-a-lifetime event becoming an annual one. A miracle becoming a routine. There is something almost bittersweet in that. We may be living through the very last years in which a visitor from another star is rare enough to stop the presses. Soon, perhaps, it will simply be another entry in a catalogue. Another faint, fast point of light logged and measured and moved past. And when that day comes, it will be worth remembering these first 3. The tailless splinter, the ordinary comet, and the ancient one, older than the sun, that passed through in 2025 and 2026, while the world was still able to be astonished by it. We may be the last generation for whom this was a wonder rather than a Tuesday, so let it be a wonder tonight, one more time, before it fades. And there is a gentler thought I want to leave you with, before we gather everything up. something to rest your mind against as you sink towards sleep. This comet has made almost everything about your life feel very small tonight. Older than the sun, older than the Earth, drifting for billions of years, bound for millions more. Against that, a single human evening is nothing, a flicker, a breath. But turn it around for a moment. In all of those billions of years of drifting, in all of that dark and cold and silence, this object was never once seen. It passed no eyes. It warmed no one. It was known to nothing. And then, for a few short months, it fell close to a small blue world. A world where creatures had learned to look up and to build machines that could catch its faint light. Creatures who could read from a wisp of gas the story of its impossible age. You are one of those creatures. You are among the only beings in the entire history of that lonely object ever to know it existed at all. That is not a small thing. That is, in its way, the opposite of small. The comet is old and vast and indifferent. But you are the one who noticed. And there is a strange, warm dignity in being the one who noticed. Hold that as you drift. You're small, and the night is large, and both of those things are all right. You do not have to solve anything. You do not have to hold anything. You only have to rest here, warm, while the oldest traveller in the sky slips quietly out toward the dark. And it is fading now, truly, as you lie here. It is out past Jupiter, in the constellation Gemini, roughly 600 million miles gone, cooling and dimming and quieting, gathering speed for the long fall back into the dark. In a century and a half it reaches the inner edge of the great cloud of comets that rings our sun. In 8,000 years it passes the outer edge and is gone, and after that nothing, only the dark and the drifting and time beyond any measure. Tonight we're going to gather the whole of it. One last time, softly, before we let it go. Remember the discovery. A telescope built out of fear, watching for things that might fall on us. It caught instead a single faint pixel of light over a Chilean desert. A pixel moving where nothing should be moving. On a path so open, so unbound, that within a day the world knew it had come from beyond the sun. Remember the burglar alarm that caught, by accident, the oldest guest it would ever see. Remember that no one was looking, and it came anyway. Remember the body of it. A frozen hill, no more than half a mile across, dark and reddish, sun-baked by a star that died long ago. Breathing out carbon dioxide instead of water. Venting nickel with no iron beside it. Wearing a cloud of invisible gas nearly as wide as the distance to the moon. Remember the chemistry no one had ever catalogued. Remember the isotopes that fell outside every fingerprint our solar system has ever made. And remember the quiet, careful voice that called it a fossil from a planetary system that formed long before our sun. Remember that we read its birth certificate in a wisp of gas, and it said, in a range of numbers that all lean the same way, older than everything you have ever touched. And remember where it is going. Out, never around, only out. Past Jupiter tonight, past the planets, toward the edge of the great cloud and beyond it. Into the dark it came from, never to return for a span of time so long it dissolves the meaning of the word. It came once, it leaves once. And you are here, awake for a moment in the middle of its endless journey, to know that it existed at all. That is the whole of it. Tonight, a stranger older than the sun drifted through, seen and named and wondered about, and now it is gone. There is nothing to hold on to and nothing to fear. There is only the quiet fact of it and the dark it returns to, and the small warm room where you are lying, safe, on a planet that formed billions of years after this traveller was already old. You do not need to remember any of it. Let the numbers go, let the names go, let the traveller go, out past Jupiter, into the dark, on its long way home. Let your breathing slow, Let your thoughts loosen and drift the way it drifts. There is nothing left to do tonight but rest. Sleep well tonight, and let the oldest traveller carry you gently down into the dark. Good night.